Hi guys, welcome to Superior Phone. How can I help you today?
Hi, how are you doing? I'm just looking to get a new phone for my daughter. She just entered high school.
Okay, so we have the Android and the iPhone. Which one would you like to get for your daughter?
Well, which one is more popular?
Well, 61.3% of people have an iPhone.
Which phone is more affordable though?
Well, the Android is going to be significantly more cheaper than the iPhone.
Yeah, I think we'll get her the Android as it's more affordable.
Oh,
But I mean, 61.3% of people is not that big of a difference.
Mom! No, way more than 61.3% of people have an iPhone.
You think so?
Yes.
Well, if you're so convinced, what do you think the true proportion of individuals with an iPhone is?
I don't agree that it's 61.3%. I think that the true proportion of people who own an iPhone at Etiwanda High School is greater than 61.3. I'm gonna prove it to you.
Well, I'll help you with that. I'm really interested in that.
Do you have an iPhone?
I do.
Do you have an iPhone?
Yes, I do.
Do you have an iPhone?
Oh, yeah.
Do you have an iPhone?
Yeah.
Do you have an iPhone?
What is this?
I know.
Do you have an iPhone?
I want to know. Like, I'm curious.
You can edit.
Oh.
So close.
Stay there. It's 0.5.
Oh, why? Okay, I guess that's fine.
I know. Now you're too far.
Bro, okay, go
Yeah.
ahead. Do you have an iPhone? Yes. Do you have an iPhone?
No, I don't.
Okay, we finished collecting the data. Okay, so we are estimating the true proportion of individuals with an iPhone at Etiwanda High School. Our p-hat is 88.636%, and our alpha is going to be 0.05. Our HO is p equals 61.3%, which is going to be the true proportion of individuals who own an iPhone, and then our HA is p is greater than 61.3%.
So for our hypothesis test, we chose to do a one property test. We got our data by using randomness cluster sampling and the 10% rule equal to smaller than all individuals with a phone. The large count condition was also met since the population was larger than 10.
After doing the math, I found that our p-value is equal to 0.0001, which is less than the alpha of 0.05.
Given the p-value of 0.0001 compared to the alpha of 0.05, we're going to reject the HO and then support the HA that the true proportion of individuals who own an iPhone at Etiwanda High School is greater than 61.3%.
So the type of error that would occur is a type 1 error. A type 1 error would occur because we rejected the HO and we reject the HO knowing that it's correct. So this would lead us to believe that the true proportion of individuals with iPhones was not greater than 61.3%, and it was actually equal to 61.3%.
Okay, so for the confidence interval, we are again estimating the true proportion of individuals who own an iPhone. Our significance level is going to be 95%, and then our p-hat is 88.636. Okay, so for the confidence interval, we are again estimating the true proportion of individuals who own an iPhone. Our significance level is going to be 95%, and then our p-hat is 88.636.
For our confidence interval, we did a one proxy interval. Our randomness was cluster sampling, and the 10% rule was also met because 10 times 132 was less than all individuals who own phones. The large count condition was also met because p-hat was also greater than 10.
After completing the confidence interval and adding and subtracting the standard deviation from our p-hat, we got a confidence interval between 0.8322 and 0.905.
For our confidence interval, we are 95% confident that the true proportion of individuals who own an iPhone is between 0.8322 and 0.9405.
So to conclude, I learned from this project that it's very important that you input the proper numbers into your z-formulas. Not doing so can affect your final answer and mess up with your data. Keeping track and making sure not to misable information is also crucial to get the accurate results. The most important variables not to mix up are the p and the p hat, being the data that you are comparing your samples to, and the p hat being the data that you collected.
So from this statistical process, I learned that the outcomes of the hypothesis test and confidence interval will coincide with each other and they must agree with each other. I also learned that we can make inferences about our population using a sample, and this process also gave me insight on characteristics of students at my school that own iPhones.
Hi, I'm Isaac Lilly. I played the mom, and I learned that small variables, things that seem small, could play a large role and have a big effect on your final variable or on your final proportions. Like as just like something small could have been like peer pressure, could have had an influence. Like if somebody saw that their friend put iPhone, they want to put iPhone too, like to seem cool or something. And then a larger effect could have been like just the income of the area, because we live in a little bit more of like an affluent area, and so it could be that more people would have iPhones because they're a bit more expensive, and this just goes along with what we're doing. So was it what you guys expected or not?
Yes, I knew that the true proportion of people who own iPhones at my school would be greater.
And I knew it too.
Thank you for my iPhone, Mom.
Yeah, whatever. Thank you.
For
Watching!